Hello! In this video, we'll give you a quick demo of PowerAI Vision, a tool that automates the building of deep learning models based on visual data, such as pictures and videos. So let's see how it works. This is the PowerAI Vision interface that displays when you click the link from the registration email. Let me show you how easy it is to quickly build a model that detects different objects from a data set of street scene pictures that contain cars, pedestrians, bicycles, and trees, among other things. Specifically, I'd like to show you how self-driving cars can detect the objects on the street. This is a simple demo, and you can try it out for yourself for detecting other types of objects. For instance, landscapes and images, or people's faces in photos, or even recognizing soccer players in a video. Getting back to our street scene demo, we have already built, labeled, and uploaded a small dataset of street scene pictures in a dataset called Street Scene, as shown here. Let's click on the dataset. You can see some of the pictures which have already been labeled. The first one is of a car. We'll zoom in and scroll down to see it. And here's the label. Then another car. Here's a pedestrian and a small car. Here's a truck labeled as a car. We can go back and label it as a truck in future. And in this picture, we have two trees and a pedestrian. In the second picture, please note that the trees are labeled individually. Now, let's look at the tags. As you can see on the tags bar, we have already created 4 different tags that will identify the different types of objects found in our street pictures. If there's a new object that we want the model to find in this same dataset of pictures, such as buildings, we simply add that tag. Note that you'll need to go through all the pictures to label that new object in each picture where a building is found. So, let's add the new building tag. Simply click the plus button next to the tag's heading, as I'm doing here, and add the new tag, building. You can also delete the tags, but if you do, you will get a warning that all corresponding labels in the dataset will be deleted as well, in all the images where you've used that tag. Now, let's add 2 more pictures to this dataset and label them using some of these tags. Click the Select Some button, then select the first new image to be added and labeled. Once the new picture is loaded and displays in PowerAI Vision, first select the tag that corresponds to the object you want to label. We'll start with bicycle, so select the bicycle tag, and then simply draw a bounding box around that object in the image. Here, we just want the bicycle. Now we'll select the pedestrian and label some of the pedestrians. Note that when labeling objects, select one object for each label. For example, if your picture has 3 cars, you would label each of them separately. And now we'll label the car. Note that if you change your mind on any of the labels you add, you can move or resize the bounding box by dragging the whole box or just the border to where you want it. Or if you change your mind altogether, you can even delete it by selecting the bounding box you want to delete and clicking the Delete Selected button, as I've done here. Then we click Save. Let's try labeling another picture. Again, after it displays, follow the same simple process. Select the tag and identify the corresponding object in the picture. In this picture, I'd like to label just the 2 bicycles and the car. And then I click Save. It's as simple as that. Remember that you can constantly edit and correct the labeling you've applied in your dataset, or add new tags or new pictures as I've shown here. Please note that you can delete any of the pictures in the dataset by clicking on the X on the top right corner of the picture you want to delete. These 2 new labeled images are now part of the street scene dataset. Our model will be trained on all the images and corresponding labels that we've added. So, as you can see, it's really quite simple to build a training dataset. An important thing to note is that the labeling can and should be done by the people who understand the subject matter the best and who know what the objects represent. In these images, anyone can label cars, pedestrians, bicycles, and trees. But for more serious subjects or tag names, such as labeling pictures of different moles for cancer detection models, you would really want someone who is trained and understands the different types of moles and different types of models, and thus can label the pictures accurately and concisely. And to do all of this, all they would need is their computer and a browser. They don't need to be a data scientist to label pictures accurately. Next, to create the deep learning model that can identify street scene objects, we'll need to create a new deep learning task, which is quite simple. All we need to do is create a new task, selecting Object Detection and giving the task a name. In this case, I will call the task Street Scene Object Detector, so that we know what the resulting model can do. Note that you can simply use the system defaults, or you can customize the process to determine how many iterations of the training to go through and which parameters to use. For this demo, let's use the system defaults because they work quite well. Then, confirm that you want to build your model, and the building of the deep learning model starts. In the background, what's happening is that 75% of the images in the dataset are being used for training, and the other 25% will be used for testing the model, even though all the images are labeled. That is, the labels in the testing portion are not used in the training of the model. So, as PowerAI Vision builds this model, and as it's being trained, it's using the training images in the dataset itself for training, and the rest for testing, and iterating them 4,000 times, which is the default number of iterations it'll go through if you select System Defaults. This is to build up new insights on new patterns in those images. PowerAI Vision is also regularly comparing them to the test dataset that we've already tagged to confirm how accurate the model is. And this is all reported back through the process as it goes through each iteration. PowerAI Vision displays the accuracy as shown here when you hover over the lines of the graph. This is showing you how many images were lost through the training, and also how many of the test images were misidentified. As PowerAI Vision continues to build the model, this graph will extend until it has reached the 4,000 iterations, showing you accuracy levels as well as progress over time at set intervals. Once the training is finished or completed, as shown here, at the end of the graph you can see that starting at the midpoint where the two lines converge, the graph shows that the loss is dramatically reduced. In fact, we can also see from this graph that we didn't need the full 4,000 iterations. 3,000 iterations or so would have sufficed. Once the model is trained, you can see it in the Trained Models section, as shown here. You can see what objects it was trained to detect, and it will give you an indication of how accurate it is, based on the information that we provided. That is, based on the results of the test images that were held back for testing. Now, once it's trained, we need to deploy the model to make it ready for use. That is, accessible to programmers and developers who can use it to build other applications. In the deploy phase, deploying the model is as simple as clicking the Deploy button from the My Trained Models section. So, in just a few seconds, we already have a web-facing API that anyone can use, and we'll use it now ourselves to test an image that the model has not seen before. Let's try posting a new, unseen image directly to this API to see what objects it identifies. We select a picture that the model hasn't seen before that contains all or some of the objects that were labeled. The response from the API comes back in JSON format, showing which objects have been detected. As shown here, the numbers after each of the labels indicate the confidence level. From these confidence levels, we can be confident that the model accurately identified the objects that it was trained to detect, with a high confidence level on 4 objects. We can conclude that our model is indeed accurate at selecting objects from street scenes, such as cars, pedestrians, bicycles, and trees. Not only that, but it can do so in a matter of seconds. So now you've seen the whole process, from beginning to end, and you saw exactly how quick and easy it was to create, deploy, and test your model. In summary, you've seen how PowerAI Vision can be used to create a dataset, identify some objects in that dataset, tag and label those objects, build a deep learning model based on that information, and deploy the model in a way that anyone can use. So, now you know how easy it would be to quickly get insights from your own pictures and videos. Thank you for watching this video.